here we have to find the possible number of regular graphs of order 4. To solve this particular problem, first of all we need to know what is regular graph. Regular graph is a graph in which degree of each and every vertex is same. As the order is 4, the possible graphs would be here in this graph, the degree of each and every vertex is 0. Other graph would be here the order of each vertex is 1. Next graph would be we can see the order of every vertex in this graph is 2, and the large possible graph would be G4. In G4, the order of each and every vertex is 3. So these are the possible regular graphs of order 4. So C is the correct option for this question. 4 sequences are given and we need to identify the sequence which results in a simple graph. If we consider option A, here there are total 7 vertices and 2 vertices are of degree 6. That means these 2 vertices are having edges to all the remaining vertices. That means the minimum possible degree should be 2, but here we are having degree 1. The minimum degree is 1. Hence we can eliminate this option A. And if we see option C, here the number of odd degree vertices are odd. This is odd degree, this is odd degree, and this is odd degree. But we have a property in a simple graph, the number of odd degree vertices should be even. But here we are having odd number of vertices which are having odd degree. Hence we can also eliminate this option. And if we see option D, here the number of vertices are 5 and the maximum degree is 5. That means this vertex is having edge to all the vertices and the edge to itself. That means this vertex is having loop on itself. Hence we can eliminate this option also. Let us apply Havel-Hakimi theorem. Havel-Hakimi theorem to option B. Here option B is 1, 2, 2, 3, 4, 4. In order to apply Havel-Hakimi theorem, first of all we have to arrange the degree sequence in decreasing order. That means this sequence would be 4, 4, 3, 2, 2, 1. Here remove this vertex and also remove the corresponding edges. Means 1 minus from this 3, 2, 1 and 1, 1. Repeat, and if we repeat the above step, we will be getting 1, 0, 0, 1. let us see if we can construct a graph with this sequence. If we take 4 vertices like this and one edge like this, 2 vertices will be having degree 1, these two, and the degree of these two vertices is 0, 0. So with this sequence we can construct a simple graph. Hence here correct option would be option B.
The given matrix is A is equals to 6, 10, minus 2, minus 3. Now we have to find the trace of A power 10. Now first of all, let us see a property. If A is any matrix whose eigenvalues are lambda 1, lambda 2, lambda 3 and so on. Now then trace of A power n will be nothing but sum of all the eigenvalues raised to the power of n. So lambda 2 power n plus lambda 3 power n plus so on. Now in order to find the trace of A power 10, first we have to find the eigenvalues of A. Now in order to find the eigenvalues, we'll consider 6 minus lambda, 10 minus 2 minus 3 minus lambda is equals to 0, which is nothing but the characteristic equation. If we simplify this, we'll get lambda minus 2 into lambda minus 1 is equals to 0, which is nothing but lambda 1 is equals to 1 and lambda 2 is equals to 2. That is, the eigenvalues are 1 and 2. Now according to the property, trace of A power 10 will be lambda 1 power 10 plus lambda 2 power 10, which is 1 power 10 plus 2 power 10. That is nothing but 1025. Option D. It is given that G is a cyclic group and is asking G power R of order 8. That means he is asking you to find the generators of G power R of order 8. Now the generators of G power R will be nothing but co-primes of 8. So R must be a co-prime of 8. That is 1 is a co-prime of 8, 3 is a co-prime of 8, 5 is a co-prime of 8, and also 7 is a co-prime of 8. So the generators are G power 1, G cube, G power 5, G power 7, which is option C. It is given that X is a random variable with the following probability density function. Now the probability density function is given as f of x is equals to kx if x is in the interval 0 to 10, and it will be 0 otherwise. Now he is saying that k is a real number and we have to find the probability of that x, probability of x in the interval 2 to 3. Now in order to find this, first of all we have to find the value of k, which is a real number. Now we know that sum of all probabilities will be always equals to 1. So minus infinity to plus infinity f of x dx will be equals to 1 by the definition of probability distribution function. Now this f of x is nothing but kx, since we are not considering infinity to infinity and it is given as 0 to 10. So if I consider the values from 0 to 10, f of x will be nothing but kx, and which will be equals to 1. Now if we integrate, it will be x square by 2 between the limits 0 and 10. And if we simplify, the value of k will be 1 by 50. After finding the value of k, now what do we need? We need to find the probability function in the interval 2 to 3, which is nothing but kx. Now the value of k is known here, which is nothing but 1 by 50. So x dx, so again it is nothing but 1 by 50 x square by 2 between the intervals 2 to 3. If we simplify, the value will be 1 by 20, which is nothing but option A.
An 8-way set associative catch is made up of 32-bit words.